Hi, my name is Azri, and today I'm going to talk about different IoT protocols. There are several protocols that are commonly used in the Internet of Things to enable communication between devices. However, we are only going to discuss about four of the protocols, which is ZigBee, MQTT, TCP, and COAP. So, firstly, ZigBee. It is based on the IEEE 802.15.4 and it operates on the physical and data link layers of the OSM model. ZigBee is often used where power consumption and cost are important considerations. It provides a mesh network topology allowing devices to communicate directly with each other or through intermediaries. Next, MQTT. MQTT is a lightweight messaging protocol that is designed for machine-to-machine and Internet of Things communication. It operates on the application layer of the OSM model and uses a publish-subscribe model where clients can publish data to a broker and other clients can subscribe to receive the data. TCP. TCP is a transport protocol that is designed to establish a reliable connection between devices. It operates on the transport layer of the OSM model and uses a three-way handshake to initiate a connection to ensure reliability through retransmission and flow control, and to tear down a connection it is no longer needed. COAP. COAP is a web transfer protocol that is designed for resource-constrained devices and networks, such as those in IoT application. It operates on the application layer of the OSM model and however it is similar to HTTP but it is designed to use less bandwidth and to be more suitable for low power devices. While these protocols can't directly communicate with each other because of the layer on which they operate, however, there are gateway and bridges that can translate between the different protocols and make them compatible. For example, a ZigBee device can communicate with MQTT broker via a ZigBee MQTT gateway, or a COAP server can send a request to TCP server via a COAP TCP proxy. Next, I'm going to talk about a different application of the Internet protocols mentioned earlier. So firstly, ZigBee is commonly used in home automation system where to wirelessly connect devices such as lighting, thermostats, and security system. For example, ZigBee-enabled smart thermostat can communicate with ZigBee-enabled light bulbs to adjust the lighting when the temperature changes. It is also used in industrial control systems to connect sensors, actuators, and many other devices to control and monitor equipment. Next, for MQTT. MQTT is commonly used to connect and control smart home devices such as thermostat, security cameras, and lighting systems. For example, an MQTT-enabled sensor in a factory can publish data on a machine performance to an MQTT broker, which can then be subscribed to by a dashboard displaying the data, alert system, or other monitoring system. It is also commonly used for fleet management, weather monitoring, building automation, and many other remote monitoring applications. Next, for TCP. TCP is known for its underlying transport protocol for many common internet services and applications such as web browsing, file transfer, and emails. For example, when you use your web browser to access a website, your devices establish a TCP connection to the web via to the web server hosting the site, and the data is then transferred over the connection using a HTTP protocol, which runs over on top of the TCP. Yeah. Next, for COAP. COAP is used when IoT application where devices are connected over the internet, such as smart city, smart agriculture, and smart building. For example, a COAP-enabled sensor in a smart city could report its measurement to a COAP server, which can then forward the data to a dashboard monitoring system or trigger action based on the data. COAP can also be integrated into a larger system and combined with other protocols such as MQTT to provide a more comprehensive solution for IoT devices. Yes, I'm going to talk about one example of an attack on one of the internet protocols that I mentioned earlier. So one of it is known as ZigBee worm, which is also known as a black energy worm that is a malicious software that was discovered in 2014. This worm specifically targeted devices that use ZigBee wireless protocols. such as light bulbs, thermostat, and home security system. The worm was able to spread rapidly between the devices by exploiting a known vulnerability in the ZigBee protocol. The main target of this worm was appeared to perform a DDoS attack on its specific targets. The worm was able to launch the DDoS attack by using the affected devices such as a botnet. The worm was then able to steal login credentials and other sensitive information from the affected devices. While the origin of this ZigBee worm is not entirely clear, it is believed to be developed by a state-sponsored hacking group based on Russia. And the group was also known for its previous campaign targeting industrial control systems and critical infrastructure. This attack highlights the importance of securing IoT devices as they can be vulnerable to various types of cyber attacks. Next, I'm going to talk about Strike, which is a threat modeling methodology that helps to identify and prioritize potential threat to a system. As you can see here, Strike stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privileges. So, in the context of Strike, an attack vector is a means by which an attacker can gain access to the system or network and initiate an attack. For example, in Strike, in a spoofing attack, the attack vector could be a phishing email that tricks the user into providing their login credential. And then the attack path would then involve the attacker using those credentials to gain access to the system. The attack surface would then include all the potential vulnerabilities in the system that could be exploited by an attacker who has gained access. Another example is in a tampering attack, where the attack vector could be in a vulnerability in the web application that allows the attacker to modify the data. The attack path will involve the attack path will involve the attacker exploiting the vulnerability to make changes to the data, and the attack surface will include all the potential vulnerabilities in the system, which could then allow an attacker to modify the data. So now I'm going to link a smart home device, smart home network to the attack model that I mentioned earlier. So a smart home network can be vulnerable to many of the same attacks as any other network system. The attack path, vectors, and surface for a smart home network can vary depending on the specific devices and system in place. By using Strike, there are just a few elements of how the Strike threat modeling can be applied to a smart home network. To fully cover a attack model of a smart home network, a complete assessment of all the devices and systems in place, as well as all potential attack vectors, paths, and surfaces should be necessary. So, to provide a full coverage and to prevent attacks on a smart home network, a combination of security measures should be implemented. I'm going to include only two examples, which is spoofing and tampering, to relate to the previous attack model that I've given earlier. So for spoofing, I recommend to implement strong authentication methods such as two-factor authentication or biometric authentication. This can help to protect against spoofing attacks. Additionally, we can educate users on how to identify and avoid phishing and using any other social engineering tactics. And next, for tampering, I would recommend to regularly update software and firmware on smart home devices, which can help to prevent tampering by patching known vulnerabilities. Additionally, I would also recommend to implement access control such as role-based access, which can help to limit the attackers to make changes to the system. This is important to note that these are just some of the examples used to prevent an attack on a smart home network. A full coverage prevention plan would need to take account all potential attack vectors and attack path and attack surface that are relevant to a specific smart home network. Additionally, it is important to regularly assess and monitor all the security and network of the smart home devices and to update the security measures accordingly. So with that, I'm going to end my presentation. Thank you.